Greetings, friends. We're going to do some practice problems, much like the ones that will be on the quiz tomorrow. You are welcome. Here we go. So let's start with multiplication of fractions. If you've got 2 over 15 times 5 over 8. Again, you have 2 15ths and 5 eighths. If you're multiplying these two ideas, you just go straight across. That's what's awesome about multiplying fractions. 2 times 5 on top, and 15 times 8 on the bottom. Now you can just keep going horizontally if you'd like and say 10 over whatever 15 times 8 is, 120. And then you could simplify. Since they both end in 0, you can divide 10 on each. 10 divided by 10 is 1. 120 divided by 10 is 12. So you will get the answer 1 over 12. If you didn't want to go this route, you could stop right here and see that each of these contain a 5. Divide each by 5 and you get this. Then you can see that each of these has a 2 and you get this. Multiply across the top and you still end up with the 1 and you still end up with 12, 1/12. Either way is fine. Just remember, when you're multiplying fractions, you multiply straight across. Here we go. What happens when we divide fractions? Let's see. We've got 21 over 58. And if we divide 3 over 16, we know the rule is to keep the first, change the sign, and flip the second. As we do that, we remain with 21 58ths. Change the sign to multiplication and flip the second. So on top, again, we go straight across, and with the denominators, we multiply them as well. 21 is multiplying 16, as 58 is multiplying 3. Take this moment to pause and see if you can find anything in common. Before you multiply 21 times 16 and try to get a really big number, let's see if we can divide a common factor from the numerator and the denominator. This sticks out to me, the fact that these both have a 3. 21, when you divide 3, you get left with 7. 3, when you divide 3, you get left with 1. How about 16 and 58? Since they're both even, I know that 2 would work with each. So 16 divided by 2 is 8. 58 divided by 2 is 29. So across the top, we've got 7 times 8, which is 56. And then 29 times 1, 29. That's your answer. Some might write it as a mixed number with 27 29ths, is it? You have 29 with 27 left over. So that looks good. Okay, here's an example of an equation that we'd have to solve. Now, as we look at this equation, it's a very simple one-step equation, actually. It's just like this equation, 2x equals 8. You've got a variable being multiplied by some number. In this case, it's being multiplied by 4/5. In this case, it's being multiplied by 2. So the same strategy exists. If x is being multiplied by 2, divide 2. If you do it on one side, do it on the other side. So you can see that x is worth 4, and you're done. It's the same strategy we're going to take for this one. We've got t is being multiplied by 4/5, so let's divide 4/5. But remember what happens when you take 4/5 and you're dividing 4/5. That's the same as taking 4/5 as it is, changing the sign to multiplication, and flipping the second. So instead of dividing 4/5 like so, we could multiply 5/4 and it would be the same thing. So let's do that. Let's forget about dividing by 4/5 like this, and let's multiply by 5/4 because it's the same thing. Multiply on this side, and let's multiply on this side. So Over here on the right, you have 5 times 4 over 4 times 5, and you still have t. On the left, you have negative 8 times 5 over 11 times 4. We set it up like this on purpose so that the t would become isolated. 5 times 4 is 20. 4 times 5 is 20. 20 over 20 is 1. T. There it is. Or you can see that these 5s will cancel, these 4s will cancel, and you'll be left with the t. Easy steezy. Over here on the right, before you multiply, see if you have a common factor. And we do. We have a common factor of 4 in these two numbers. 8 divide 4 is 2. 4 divide 4 is 1. Across the top, you've got a 10, 2 times 5. And on the bottom, you have 11 times 1, 11. Don't forget, that was negative. Boom. That's your answer. Maybe you need another example. If so, watch the next one. Same looking equation, we can either multiply through by the LCD, or since it's a simple one-step equation, you can multiply by the reciprocal, and that's another way to solve this. Notice, you can tell the story. X, what's happening to x? It's being multiplied by 14/27. So really, the strategy is to divide 14/27 on both sides. However, dividing by 14/27 is the same as multiplying by the reciprocal, 27/14. And as long as you do it on both sides, you're not changing anything, and you're isolating x. Because these will cancel, you're left with x. And on the right side, you have your answer already. 7 times 27 and 12 times 14 on the bottom. It would be great if there was something that canceled out here. Remember, that's negative. And something does. 7 and 14, they both have a 7. 7 divided by 7 is 1. 14 divided by 7, 2. How about 12 and 27? I can see a 3 they have in common. 12 divided by 3 is 4, and 27 divided by 3 is 9. When you multiply 1 times 9 on top, you get 9. And when you multiply 4 times 2 on the bottom, you get 8. And you're done. How about that? Pretty crazy. On page 267, there's some more practice problems. I've actually done a couple of examples from that page here. You can get some more practice on page 267 in your text. Let's keep going. Okie dokie, this is where it gets intimidating because there's a fraction and a fraction and a fraction, and it's all in an equation. Scary stuff, I know. But the process here is to multiply through by the LCD. This will make all your fractions go away. No more fractions. What a great life that would be. And you can do it by multiplying through by the LCD. So take a look at 9, 6, and 54, your denominators, and figure out what the LCM between all of them is. Once you do that, that's your LCD, or least common denominator. What you should do is take a sneak peek at the biggest one, 54. If 9 and 6 go into 54, that's your LCD. And it just so happens they do. So let's take 54, and let's multiply every single term by that 54. When we do, we have this setup. 54 is multiplying this first term, 54 will multiply this second term, and 54 will multiply this last term. So no tricks up my sleeve right now. We're just multiplying through by the LCD. When we do that, we have 54 multiplying 8 over that 1 is multiplying 9, so that's just 9. You still have this x, and be careful, it's a positive multiplying a negative. The result will be negative. Oops, maybe you caught this mistake. I didn't put the 4, but it's okay. We still got 54 multiplying 1 on top, so I think that's still 54, and 1 multiplying 6 on bottom. That's a 6. And lastly, we have 54 multiplying 49. Please don't do that, because that would be obnoxious. And we have a 54 on the bottom. When we go back to simplify this, we've done this on purpose so that these two ideas have something in common. Notice they both have a 9. Divide this by 9 and you get 1. Divide this by 9 and you get 6. So really, the result is 6 times 8 on top, 48, with the x, and it's negative. Here, these were designed to cancel out. 54 divided by 6 is the 9. And here, look, it canceled out beautifully. 54 divided 54 is 1, times 49 is 49. Couldn't have asked for something that looked any better. Now, we have an equation. We have an x that's being multiplied by negative 48 and added with a positive 9. So let's do the opposite on both sides. We've got 40. And we got 48x, negative 48x. Now you can still tell yourself the story. And let's see if we can make this a little smaller so we have room. Here we go. Let's tell ourselves the story. X is being multiplied by negative 48, so divide. Negative 48 on both sides. X will be equal to 40 over 48, and it's negative. You can simplify this a little bit. I can see a 2 that's present in each. If you divide each of them by 2, you end up with this. Oh, you can keep going. Actually, a 4 is present in each of these, so divide each by 4, and you can see that 5 is over 6 is your final answer. But I hope you didn't forget that it was negative. Hooray! Here's your last example. You've got an equation with a bunch of fractions. If you could, try to find the LCD and multiply through. What is the LCD? Well, take a look at the biggest one. Does 14 go into 42? I think it does. 3 times. Does 7 go into 42? Yeah, 6 times. So 42 works as your LCD. Let's take it and multiply every single term in the equation by 42. Let's just set that up so we stay organized. Multiplying the first idea, keep the signs the same as you multiply the second. And lastly, oops, you've got, this is a 42 multiplying 19 over 42. So that'll work out nicely. Now we've got 42 is multiplying 3 over the 1 that's multiplying 7 allows 7, and you still have this x. Next, 42 is multiplying 5 over the 14, and lastly 42 is multiplying 19 over the 42. So I hope you notice what's happening. It's the number outside the LCD that's being divided by the denominator. And we made it to where it divides evenly. Like 42 divides 7, we know is 6. So when you come down here, it shouldn't be a surprise that these have a common factor of 7. When you divide the bottom by 7, it's 1. When you divide the top by 7, it's 6. Of course, we made it that way. 6 times 3 is 18 with an x. Now, 42 is designed to divide with this 14. You see it? Each has a 14. This one has just 1, and this one has 3. 3 times 5 is 15. And lastly, these will divide, of course. We made it that way for 19. Now you tell yourself the story about x. It's being multiplied by 18, and you have a positive 15. Let's do the opposite, negative 15 on both sides. So you can see 18x's is equal to 4. And the very last step to get x by itself is divide 18 on each side. So x is worth 4/18. Oh, you can divide each of those by 2. How about 2/9? Hooray! Good luck. Talk to me if you have any questions. Talk to me if you don't have any questions. You're still allowed to do that. See you later. Toodles. Bye. Illy.